So this is section 2, A, B, and C, and we're talking about problem solving. So it says it starts off with a scenario and basically says you're expecting a child, you want to paint a nursery. The nursery is 6 feet long, 8 foot wide, and 7 feet high. One paint brand advertises that one standard paint can holds enough paint to approximately cover 25 square meters. You want to do a good job, and it's a lighter color, so you know you're going to need 3 coats. You can work only an hour and a half per day, and the contractor says it'll take him at least 4 hours for 3 days of painting, but he'll have to let it dry between coats for at least 24 hours. So there's some questions that you're going to be asking. How many paint cans will you need to buy at $12.35 per can? How much will it cost to paint the nursery? If you hire someone else to do the work at $18.50 per hour, how much will that cost? Would it be better to have a contractor to do the work or to do it yourself? If you weren't someone who was used to doing these kinds of work, then how would you begin to approach the problem? Maybe you're going to wing it and paint it yourself as you can afford it. However, paint colors are mixed independently, and one color can be a shade or two different if mixed by a different person in a separate patch. So you really need to buy all the paint color at the same time. Or perhaps you'll trust the contractor to do the work for you, even though you can't be there the entire time to ensure the work gets done correctly. But how will you know if the prices they quote are reasonable, or that they aren't buying more paint than they'll need in order to sell the excess for profit behind your back? So you would have to consider this stuff one thing at a time. One thing we do when we work these types of problems is we use something called dimensional analysis, which is kind of scary. We use it a lot in chemistry, but we also use it when we're trying to make conversions of anything. So the first example says you need 3 pounds of bananas to make your famous banana bread at $1.79 per pound. How much will you end up spending on bananas? Well, we've got some stuff we know. We've got 3 pounds of bananas. So if we've got 3 pounds of bananas, that's what we know. I would start off here and say, well, I've got 3 pounds. And at the end, right, the question is, how much will you end up spending on the bananas? So we know that in the end, we need something to be dollars. Our answer needs to be dollars. So the other thing that we know is that they're $1.79 per pound. And we kind of talked about this in lab, but we can write this as a division. $1.79 per it means the same thing as division, per pound, so per 1 pound if there's no number there. Okay, and so we talked about how we could use that to get something to cancel out. So if we put the $1.79 on the top and we put the 1 pound on the bottom, then that's going to be good, because if you've got a unit that's the same on the top, on the bottom, then on the bottom, they're going to cancel out. And so we're going to have 3 times $1.79, and that's going to get me $6.78. On the bottom, all we had left was a divided by 1. When you divide by 1, you're going to get the same thing. A lot of people, when they're doing these dimensional analysis problems, will make kind of like a T to organize their work, and we'll talk about that a little bit more. Okay, we've got a car that travels 25 miles per hour. How fast is it going? Okay, so we're starting out. Here's what we know. We've got 25 miles every half of an hour. I just go ahead and write a statement. Okay, half of an hour would be 0.5, right? We've got 25 miles every half of an hour. That's one thing we know. And that's kind of where we're starting at. We've got 25 miles. And we can do that every half of an hour. Okay, we're going to have to multiply by something. We want the answer to be how fast is the car going? Well, we need to end up with miles per hour if we want to know how fast the car is going, right? So we need a statement that has to do with miles per hour. Now, if you'll notice on this one, this is miles per hour and this is miles per hour. So actually, we don't need to multiply by anything here. We just need to divide 25 divided by to figure out the answer to go from here, because we don't want to know how much we can go in a half hour. We want to know how much we can go in 1 hour, right? So we just need to divide 25 divided by 0.5, and that's going to get us 50 miles in 1 hour. That's going to be our speed. Okay, a raised flower bed is 25 feet long, 7 feet wide, and 1.8 feet deep. Find the area of the bed and the volume of soil needed to fill it completely. Well, to find the area, we're going to need to do, all right, length times width. Well, it gives us some information. It says this is the length because it's 25 feet long. This is the width, 7 feet wide, and this is the depth. Sometimes we call that the height. Okay, so the area is just the length times the width. So 25 feet times 7 feet. Okay, if you do that calculation, you get 175. But what do you do with the feet here? You've got feet times feet. Well, when you multiply the same thing by itself, right, it's going to be feet squared. Okay, let's talk about the volume. Okay, to get volume, we want to do length times width times height. So 25 feet times 7 feet times the height, which is 1.8 feet. Okay, we've got feet times feet times feet. Now that's feet cubed, right? We've multiplied feet 3 times, so volume is feet cubed. And 25 times 7 times 1.8 turns out to be 315. Okay, and it says, what is the total cost of the soil, right? What is the total cost of the soil if it sells for $17 per cubic foot? So, right, this is a fraction. $17 per cubic foot, which is feet cubed. There's no number here. If you want to put a 1 there, you can, but that's what that is. And so what we know is if we're going to fill it with soil, are we talking about area or volume? Area is just the measure of something that is one-dimensional, right? Volume is actually filling something up. And so we want this. So if we start out with our 315 feet cubed, okay, and we need to, in the end, we're wanting the total cost, so we really just want to know how many dollars. What we're going to need to do is we're going to need to get rid of feet cubed. Well, what we have to use is this. Okay, so if feet cubed is something we want to get rid of, and it's on the top, we really want it to be feet cubed on the bottom. Whatever our fraction is has feet cubed on the bottom, so that this feet cubed will cancel out with this feet cubed. Okay, so I'm going to put my 1 here. We've got $17 on the top. I just got that information from this fraction. Okay, and I put these in this place because these are the ones that needed to cancel out. So my feet cubes are going to cancel out. 315 times 17 is $5,355. And then the only thing I had left on the bottom is a 1, and dividing by 1 is just going to keep our answer the same. Okay. So unit conversion. To change feet to inches, we know that 12 inches is in 1 foot, which is equal to 1. Such a term is called a conversion factor. All conversion factors can be written in 3 ways, and we've already kind of introduced this. We can say 12 inches over 1 foot is 1. We can say 12 inches is equal to 1 foot, or we can flip it, right? 1 foot over 12 inches equals 1, because these are equivalent to each other. That would be like saying 7 divided by 7. 1 foot is exactly the same as 12 inches. Okay, so really it's important to know that you can flip this fraction upside down and it's the same thing. So the first problem here says to convert 12 feet to inches. So I'm going to say 12 feet. And in the end, right, I want my answer to be in inches. That's how I always start these problems. I want my 12 feet to turn into inches. Okay, so to do that, I'm going to have to multiply with something that has feet down here because my answer is not in feet. It's in inches. So I need these feet to cancel out. Okay, well, if you look up here, this one right here has feet on the bottom. So I would put 1 foot, 12 inches on the top. My feet cancel out. 12 times 12 ends up being 144. Okay. Convert 201 inches to feet. Okay, so we know we're starting out with 201 inches. I want my answer to be in feet. So guess what? I need whatever's down here to be inches and feet to go on the top. So how many inches are in a foot? There are 12 inches in 1 foot. So on this one, I'm actually going to have to, when I multiply across, I'm going to get 201 times 1, which is 201. And on the bottom, I do have something besides 1. There's nothing here, but I've got a 12 here. And my inches canceled out. So to finish this problem, I'm actually going to have to go, what is 201 divided by 12? And that gets me 16.75 feet. Okay. You are on a vacation in Mexico and you need cash. How many pesos can you buy with $150? Use the exchange rates in the table and ignore the transaction fees. Okay, so if we want to go from dollars to foreign, dollars divided by what the foreign currency is, this is this number. The foreign currency divided by the dollar is this number. Okay, so what we know is that we have $150. That's where we're starting out at. And we want our answer to be in pesos. I'm going to have to divide by dollars. That's the only way the dollars are going to cancel out. So I need to know how many pesos are in a dollar. So I'm looking at my chart here. Here's the information that we have. And we've got, this is this is whatever the foreign unit is, so divided by the dollar, right? Which we've got pesos divided by the dollar, so we want this category right here, the foreign divided by the dollar. Well, that's 21.86. If we wanted to, we could put a 1 down here. We don't have to. So we would say 150 times 21.86, and that ends up being 3,279 pesos. And we could divide by 1 if we want to, but you need to realize that the dollars are going to cancel out. That's the important part. Okay. These are kind of hard for people, so let's do another example. Let's say that we are going from, let's do British pounds. And let's say we have 25 British pounds, 25 pounds. And what we want to know is how many dollars is that? So we're starting out with 25 pounds, British pounds, and we want the answer to be in dollars. Well, pounds is going to have to go on the bottom. Dollars is going to have to go on the top. We usually put the dollar sign in front instead of in behind, but so we really want something that is dollars per foreign, right? The dollar sign per whatever the foreign is. So that would be this category right here. So $1.221 per 1 pound. Okay, and so we would multiply 25 pounds times 1.221. Okay, so I'm going to multiply 25 times 1.221, and that's going to get me 30 point, and we're talking about dollars, so it says 525, so I'm going to say 53 because that 5, so I got 30.525. That 5 is going to make that 2 round up to a 3. The pounds are going to cancel out, which is what I want, and I'm left with dollars in the end. A toll collector on a highway receives $8 for cars and $9 for buses. At the end of a 4-hour period, she collected $368. How many cars and buses could have passed through the toll booth in that amount of time? So we could make an equation out of this, right? We could say, let's set X equal cars, and let's set Y equal buses. So what we could say is, well, we've got 8 cars, right? That's what that says. $8 for cars. So every car that goes past is going to pay $8. So if 2 cars went past, we'd do 8 times 2, which would be 16, plus $9 for buses. So we're saying buses are 9. And it says at the end of the 4-hour period, she makes $368. So it says how many cars and buses could have passed through the toll booth during that time. Now, one thing I could do is just do guess and check. I could plug things in for X and plug things in for Y, and I can solve it that way, okay? Another thing that I can do is use some algebra. Either way works just fine. So I'm going to show you how to use the algebra, do the algebra method. I can subtract 8x from both sides. My goal here is to kind of get y by itself. Okay, so this is going to cancel out. I'm going to have 9y just is equal to 368 minus 8x. Okay, I'm going to divide by 9 because I'm trying to get y by itself, so I'm dividing everything by 9. Okay, so 368 divided by 9 minus 8 divided by 9. And that's going to get me, this is 46. This stays 8/9 times x. I'm sorry, I made a calculation error right here. So let me go back and fix this real quick. 368 divided by 9. I accidentally did 368 divided by 8. Is, you're not going to be able to reduce that. I'm just going to leave it 368 divided by 9. It turns out to be like 40.888, and we can't have a decimal when we're doing these type of problems. Okay, so this is the first day we're kind of pulling out this graphing calculator that's nice. Now, once again, you could use guess and check. You don't have to use the graphing calculator, but I'm going to plug in the formula that we had, which we said was y equals. So I'm going to my y equals button. There's a calculator over here. You may, if this is the first time you use this calculator, you might have to go slow and rewind this video and look a couple of times. But on your calculator, so if you'll look over here, let me go with my pen. If you'll look over here at this pointer, you want to hit y equals. When you hit y equals, you're going to come to a screen that looks like this. Now, we need a fraction, and so on your calculator, you're going to hit alpha, which is the green button that's right below second. Some of your calculators, it may be a different color, but I'm going to go hit alpha, y equals, and it gives me a choice, some choices of fractions, okay? And so my first fraction that I need to pick is this one. And we said we had 368 on the top divided by 9. And then I'm going to arrow over minus, so I'm just typing in the equation that we had, and we did 8/9, so I need another fraction, alpha y equals 8/9, and then I'm going to arrow over and I'm going to hit x, and that's not x, sorry. And on this calculator, I accidentally pushed X on my keyboard, sorry. On this calculator, the X button is right by the alpha button. It says X, comma, T, comma, theta, comma, N. That's your X button, the one that's over here. So now, what I want to do is I want to look at the table. I don't want to graph this. I want to look at the table. And if I hit second graph, there's in little bitty words up here, it says table. So I'm going to hit second graph, and it's going to give me a nice table. Now, I'm not worried about what the negative numbers are, but I'm going to go down and look at what the first thing on my table. It says 0, 368 over 9. You don't want to put that. Okay, so you want to find the values that are whole numbers, and we're going to jot those down. So the first whole number, where both of them are whole numbers, x is 1, y is 40. I want to jot that down. Okay, I'm going to go on down. Okay, so I'm still getting these fractions over here, so I'm not interested in those. I'm looking for when they're both whole numbers. We can't have part of a bus or part of a car. So there's another one that I want to jot down, 10 and 32. There'll be another combination. 19 and 24. Another one we're jotting down. We're going to put that as one of our answers. 28 and 16. 37 and 8. And 46 and 0. Okay, so when I get back to, let me X out of this graphing calculator. When we get back to our answers, we want to write down the things we jotted down. So we had a table. This was X and this was Y. These we came up with 1 and 40, 10 and 32, 19 and 24, 28 and 16, 37 and 8, 46 and 0. So these are all the combinations. Remember, we said X is cars and Y is the number of buses. And so if I have 1 car and 40 buses, that should work and give me this. I'm just going to test some of them. So this was our formula, 8x, because the cars were $8 a piece, the buses were $9 a piece, and we wanted 368. So I just want to see if I plug in a 1. We'll try this one right here out. If I plug in a 1 and a 9 and 40 for the Y, and if I type that in my calculator, 8 times 1 plus 9 times 40 is giving me 368. So there's one combination. We could have 1 car and 40 buses. Let's check this one out just to make sure we're good. So if I do 8 times 28, because they're saying I can have it, because they're $8 a car plus $9 for 16 buses. 8 times 28 plus 9 times 16. Guess what? 368. So I could have 1 car, 40 buses, 10 cars, 32 buses, 19 cars, 24 buses, and so on and so forth. Every one of these would work. Okay, this is the last example. Suppose that 8 turns of a wire are wrapped around a pipe with a length of 60 inches and a circumference of 40 inches, so that the wire reaches evenly from the top of the pipe to the bottom. What is the length of the wire? Okay, this problem is kind of difficult. So let's start with this. We're taking a wire and we're taking it around 8 turns. So I'm going to draw this out really quick. So basically we've got a pipe. We're taking this wire. Okay, so basically we're taking this wire. Now listen, we've got, this is like, pretend this is a rectangle. I know I didn't do a great job of drawing it, but if you kind of like a wrapper on a soup can, if you wrapped a wrapper around the soup can, if you unfolded it, you would get a rectangle. Well, we're taking this wire and it's going to have to go 8 turns. So it's kind of, when you wrap a wire around, right, we're talking about a cylinder. It's going to wrap around and around and around this pipe. So if you stretched it out and you folded it out, the wire would wrap around and then it would loop back around. So every time that we draw one of these little triangles, there's the wire going up again. So here's the wire, then it wraps back around to this one's going up, and then I would have another one and it would do that all the way up, right? That would be the circles that are going around, okay? So it also tells us that the length of the pipe is 60 inches and that the circumference all the way around the pipe is 4 inches. Kind of like if you had a soup can and you unrolled that wrapper, the circumference is the distance around the circle, and if you unroll the wrapper, there's our distance. So this problem's a little bit rough. Now, if we take that 60 inches and we divide each one of these, we've got 1, 2, 3, 4, 5, 6, 7, 8. Why do we have 8? Because it says it takes 8 turns around. So if we do 60 divided by 8, we get 7.5 inches. So each one of these, 7.5, 7.5, 7.5, all the way down. Okay? So the question is asking us, what is the length of the wire? Well, I've got this distance right here 8 times. So in this problem, we're going to pull out that triangle, and we're going to find the distance of one of them. Okay, let me show you what I'm talking about. So I pulled out this triangle right here. This part right here, the hypotenuse of the triangle, is actually the length of the wire. This part is 7.5. This part is always 4. Now I know I've not drawn this to scale. Those are our dimensions. So when you use the Pythagorean theorem, we've got a squared plus b squared equals c squared. Okay, A and B are talking about your side lengths. So H is your hypotenuse. This is actually what we're looking for right here. And so I'm going to say 4 squared plus 7.5 squared equals c squared, which we've called it x. So I'll just change it to x. Okay, and so I'm going to have to figure out that measurement. So 4 squared plus 7.5 squared gives me 72.25. And then I'm going to go, okay, well, I need to get rid of a squared because I don't want to know what x squared is. I want to know what x is. So to get rid of a squared, you take the square root of both sides, and that will give you the length of one of these stretches around the pipe. So the square root of 72.25 is 8.5, and this is in inches. Okay, so that's one of them. But how many do we have? We have 8 of them. So we need to take this and multiply 8.5 times 8 to get our final answer of 68 inches. That one was kind of challenging. So here we go. We've got there's some tips here that you can look at. Example 10, it says go back to page 1 of this packet and see if you can answer the questions about the painting the nursery. And here's a whole lot of conversions if you need them. You might want to print off this page just so you'll have it. It's also in your book. Okay, so that's chapter 2, sections A, B, and C.